Okay, welcome back to PMAT1100. So you know that since data is collected randomly, so when you display those data on coordinate system, sometimes it's scattered everywhere, right? However, if those data follow a linear pattern, then it will be represented by a line. In turn, a line will be represented by linear equation. So in this section 3.7, we'll be talking about how to write a linear equation given a certain description of relationship. Okay, so let's get started. Section 3.7. Writing linear equation. Okay. In order to write linear equation, we need to have a formula. Okay, and the formula to write linear equation in this course I will be introduce you will be y equal to mx plus b. Okay, and let me explain each variable over here. What is y, what is m, what is x, and what is b? Y and x is the quantity, two different quantity that related to each other in terms of linear relationship. Okay. Y, we already know that y is a dependent variable, x is an independent variable, we already learned that. Okay. M is the slope. Okay, so let me box this formula first because this one is important. It will help you to write a linear equation. Okay, b could be 0. Okay, so m is the slope. We already know that is the rate of change. You were introduced this concept in section 3.1 already. Slope or rate of change, right? Rate of change between two quantity y and x. Okay, and b is so slope intercept. We already talked about x-intercept and y-intercept. I'm sorry, this is y-intercept. We don't have something called slope intercept. So we have y-intercept value. I say its value because you see that it's only b. Okay, but if you can write it in order pair form, if you write it in the order pair form, then we have a y-intercept point. Okay, so y-intercept point will be 0 b in coordinate system in order pair form, right? And we already know that y-intercept point is an intersection point between a line and y-axis, right? So this equation represents a line. Okay, this equation represents a line. So that's why we are talking about writing linear equation. Linear means a line. So this is represent a line. Okay. So this form here we call that, we have a name for that. We call the y. Is called this is called, let me see, suddenly I just forgot. It's called y-intercept form. Okay. Point slope form, where we never learn point slope. This is a intercept form. Okay, so I'm gonna put over here, this is intercept form of linear equation. Okay, intercept form of linear equation. So this is the intercept form of linear equation. There are three forms, but in this course we just learn this form. Okay, all right. So let me see if we can jump straight to example. Anything else I need to explain over here? So oh yes, let's talk about the slope. The slope is very important. So the slope is the rate of change in the slope. The slope can be positive or negative. Okay, remark. I believe I already talked about this in previous section too, but I want to repeat it. So the slope is positive, then then the line will be slanted upward. So I mean it will be increasing line. Okay, and if m is negative, we will have decreasing line. Okay, so increasing line is something like this. Okay, and decreasing line is something like this. Okay, it's slanted upward from left to right, and this is slanted downward from left to right. Okay, and we already know how to find the slope. The slope is m equal to 1. Anyone remember? The slope formula, right? The rate of change formula will be m equal to y2 minus y1 over x2 minus x1. This is just the change of the first quantity over the change of the second quantity. So the change of dependent variable over the change of independent variable, because this is x. Okay, x2 minus x1. Okay. And so this is the formula for to find the slope. It means what? It means that if they give you they give you a set of data, a bunch of data, right, and you graph those points, they on the coordinate system, then you can pick 2 points. You can pick 2 points, and you can find the slope easily. Okay. Now let's jump to the example. Let's do the example. Because this section is kind of similar to the previous section, so I think I'm gonna just do one example. I think this is good enough. Okay. All right. So I give you a set of data. This data is collected randomly. Okay. So I have a table of data, something like this. Okay. It's not really straight down, but that's good enough. So over here we have the number of pizza bought, and on this side I have the total cost. Okay, and if we don't buy any pizza, okay, then the cost is still $10. I will explain why. Sometimes you ask me that, like, this doesn't make sense. How come how come I don't buy any pizza and the cost is still $10? But I mean, this is it's not really practical. But I mean, this is math, so we're dealing with something. I have to say that we can make up a problem, and in reality, this does not really reflect the truth at all. But I mean, as long as it's get along well with the concept we are doing here, then it's okay. Okay. Okay, so if we buy 5 pizza, then the cost is $55. And if we buy 10 pizza, then the cost will be $100. And if we buy 20 pizza, then the cost will be 145. And if we buy 25 pizza, then the cost will be 235. Okay. Then if we buy 30 pizza, then the cost will be 285. Okay, so there are 1, 2, 3, 4, 5, 6, 6 data already collected. Okay, so I'm gonna explain over here why you don't buy any pizza and it costs you $10. Okay, um, I don't think that in reality you see this type of situation, because if you don't buy any pizza, you don't have to pay any money, right? But this is a problem for you to be able to see that I can create a linear equation with all information, with all the variable here, based on given information here. Okay. So the reason I say that if you don't buy any pizza, the total cost is still $10, because I say that this $10 over here is due to delivery charge. Okay, so you buy pizza. So the question is like this: you buy pizza. Okay, and the delivery charge, so the delivery charge is $10. It doesn't matter how many pizza you buy, but the delivery charge is $10. Okay, and they also say that you have to pay $9 for each pizza. So the cost for a pizza, okay, is $9. Okay, the question is write a linear equation put it down, that describe the cost okay. Alright, so we need to write the equation that describe the total cost. So let me be more specific here. So this is the total cost. The total cost. Alright. So how will we do this? We know that the delivery charge over here is $10, and this one is fixed. It doesn't matter how many pizza you buy, the delivery charge is still $10. This is fixed. Okay, so this is the fixed cost. Remember in the previous section, we already talked about how to find the total cost, and I give you the formula. Total cost will be the fixed cost plus the cost for each item. Remember that? Okay, and plus the cost for each item. So over here, I want to write the linear equation that describes the total cost. Then the total cost will be what? The total cost. I'm gonna call it C. Okay, C is total cost. Will be what? will be the fixed cost. Okay, the fixed cost over here. The fixed cost over here is $10. Okay, okay, plus what? Plus the cost for each pizza. So over here, the cost for each pizza is X. Okay, the cost for each pizza is X. Okay, however, we don't know how many pizza we buy, but we know that just one pizza is cost you $9. So in order to find the total cost, then you need to multiply this by the number of pizza you buy. So X represent over here, X represent the number of pizza you buy. Okay, so this is the linear equation we want to have right here. So this is the answer of the question A, but I'm gonna just explain over here what X is. So X represent the number of pizza bought. Okay, so basically X is right over here. X is in this column. Okay, and the C, the cost is, which is Y. Usually we use Y, right? But because over here is total cost, so I'm going to use C. So you see that it doesn't matter what letter you're using. I mean, as long as that letter represent the variable, the correct variable. Okay, so this is the total cost. You can use Y or you can use C, doesn't matter. And this is independent variable. This is the number of pizza bought. So this is X right over here. So this is the answer for question A. Okay, question B. Question B is find the number of pizza bought you can buy if your budget is at most $175. Okay. You remember when we talk about at most or at least, right? At most, at least is inequality. Okay, and they ask you for the number of pizza. I mean, they're asking you for X, right? They're asking you for X. Okay, all right. And if your budget, which is the cost, okay, or I can write like that. If you spend, I think I'm gonna fix that. If you spend, oh, let me use different color. If you spend at most $175, okay. Okay, so if you spend at most $175, it means the cost, right? It means the cost. This number over here is the cost, right? $175 is the amount of money, the amount of money you might spend. That's this, that you cannot spend more than 175. So in order to find X, you need to create the equation. So it will be 10 plus 9X, right? And at most, at most will be less than. So this is supposed to be inequality. But they don't say that if you spend 175, but they say that if you spend at most. So then when they talk about at most or at least, we talk about inequality. So you have to create inequality. Okay, so at most will be, this will be less than equal 175. Remember last time we already talked about this. Okay, so from here I can solve for the number of pizza, the highest number of pizza you can buy. So 175 minus minus 10, it gives you 165, right? And x divide 165, you divide it by 165, you divide it by 9, so you have 18.33. So at most, I can say that at most you will have only 18 pizza. Okay, at most you can buy, okay, 18 pizza only. I mean, this 18.33, but I mean, we can rather down, because 0.33 pizza, which is, I don't know, kind of little small slice, so I don't really care too much about this. If it is like 18.85, then I'm gonna round up to 19, but it's 18.30, so I'm gonna round down. Okay, so at most you can buy 18 pizza only. Okay. All right. So I'm gonna stop right over here, but maybe some of the students will kind of ask me, what is the point of this table? What is the point of this table? The thing is that you see that in my question, I give you the cost for the pizza is 9. Cost for the pizza is 9. Okay. What if I don't give you the cost for the pizza? Okay. Okay. What if I don't give you the cost for the pizza? Let's see. We can find this number or not. What if I just give you the table? Okay. Let me see. We can find this number. So this number, you see, this number is over here attached to x. So this number 9 over here is the slope, right? It's the slope, right? So what if they don't say that the cost for each pizza is $9, and they just give you this table right here? So all you have to find is to use the slope formula. In order to find 9, you just use the slope formula. So m will be what? Will be y2 minus y1 over x2 minus x1, and you already define which one is y. You already determine which one is y, which one is x. So this is y right here, right? So on the right column is y, over here is x. So I'm gonna pick y2, y1. So y2, you can pick anything. So the y2, I'm gonna pick this one. So this is y2 and this is y1. So correspondingly, so y2 over here, the derivative will be x2 correspondingly to y2, and this is x1, right? So you can plug them in and you see the answer will be 9. What if they don't give you 9? And you can find that number 9 easily. So it will be what? It will be 100, right? 100 minus 55 over 10 minus 5, right? So 100 minus 55 give you what? 100 minus 55 they give you 45, right? And over here give you 5, and 45 divided by 5 give you 9. 9 pizza. Okay, $9 for one pizza. There you go. So that is how you can come up with number 9 over here. But you see, in this problem, I give you the information already, which is easy. But sometime on the test, I just give you the table. Then you have to figure out the slope, which is the price for each pizza, okay, based on the table. But if they don't give you the table, and they said, then they must give you this, okay. Okay. Or if they sometimes I don't need to give you the table, I just need to give you these two information. Then you can also find the slope, the price for each pizza. Okay. All right. So that is how you write a linear equation based on the data. Okay. Okay, you're gonna start using y equal to mx plus b. Okay, so I'm gonna stop our lecture 3.7 over here. That's a kind of very short one. Okay, I will be see you in next time in section. Let me see. Uh, section 3.8, and that is the last section for unit number 3. Okay, thank you so much, and see you next time.